Hi, we are going to do ADM7 lesson 12, decimal expansions of fractions, part 2. This is a lesson that it's conceptually interesting. Certainly I'm going to give you a lot of homework help on this in this lesson. This isn't the way that you'll always do decimal expansions when you're given a fraction, but it's good, again, conceptually to understand it. Your teacher may really want you to know this. So let's go over this and let's get through it and hopefully have some fun today too. Let's get to it on our application window. And here we are. All right, so the goal of the lesson, again, is to learn a method for converting fractions to decimals, not using long division. So typically, if you're given a fraction like 3/4, you can convert it. You know, you're going to use long division to find the answer to the problem, 0.75. And you'll get there pretty quickly. Now, there's another method if you don't like long division or you conceptually need to understand it, how to iteratively find each decimal place in the decimal expansion of the fraction. So that's the whole key. So we're going to look one digit at a time, and we're going to not use long division, and we're going to find each decimal place in the expansion. And again, honestly, I would not use this method as a general method for solving lots of these problems, but it's conceptually interesting again. So if you have a decimal or a fraction like 3/4, the decimal representation is going to have a 10th digit. So it's going to be between 0.6 and 0.7, or between 0.7 and 0.8, or between 0.9 and 1.0, or between 0.3 and 0.4. It's going to be between one of these pairs of numbers, or 0.1. There's 0.0 and 0.1, 0.1 to 0.2, all the way. They're all 10 combinations. It's going to be somewhere in there. So what we're going to do is we're going to say, well, each one of these numbers is represented by m over 10. So if we had 0.3, that would be like between 3/10, and then m plus 1 would be 4/10. So maybe it's between these two numbers. Well, we got to figure out what the m is so that it's between those two 10th digits. Okay? So it might, and I'll come back and we'll rework this after we know the answer. But we know the answer is 0.75, by the way. We just did that math. So we're eventually going to find a number between we're going to find this between 7/10 and 8/10. But let's just go through this. And we're going to use this method right now. Okay, so we know that whatever 10th digit and whatever 10th digit that's one bigger than it, is going to be on either side of 3/4. So what we're going to do is we're going to take both sides and multiply them by everything and multiply it by 10. And we can do this by the multiplicative property of inequality. So we're going to multiply this by 10, this by 10, and this by 10. And if we do that, m over 10 times 10 is just m. M plus 1 over 10 times 10 is m plus 1. Well, 30 over 4 times 10 is 30 over 4. Well, now it's pretty easy to see that our m has to be 7 because 30 over 4 is between 7 and 8. We can see that, right? 30 divided by 4 is 28. 28 4 goes into 28 even 7 times, but it doesn't go to 32. If this was bigger than 32, we'd have to use maybe the number 8. But 34 is between 7 and 8 because 30 over 4 is 7. And we're not going to do long division to keep finding all the rest of the decimals, but we know that the right number here is 7. Okay, so 7 is less than or equal to 34, which is less than or equal to 7 plus 1. So our 10th digit is 7. Okay, so we're going to write that down. Our 10th digit is 7. So we know that this number that's 3/4 is greater it's greater than or equal to, or it's less than, is 7/10. Whatever that number is, it has a 7 in the tenths digit. So there's our 7 over 10. And now we're going to look for the hundredths digit. So we're going to say, well, what's the hundredths digit that's just smaller than 3/4 or equal to? And then this 3/4 is also less than 7/10 plus some other hundredths digit that's one greater than. That's one greater than this hundredths digit that we're looking for. So it's between like 0.7, 1 and 0.72, or between 0.72 and 0.73. So we're hunting for this digit, and this is our new m. Okay? I know this is a little bit deep, but this is kind of a conceptual method for just kind of iteratively finding our answer to the question of what is the hundredths digit, now that we know that the tenths digit is 7. Okay, so if we have 7/10 plus m over 100 is less than or equal to 3/4 is less than 7/10 plus m plus 1 over 10, then we know that we can use the subtraction property of equality. So we're going to subtract 7/10 from all three pieces. So if we subtract 7/10 from here, minus 7/10, we get just m over 100. If we subtract 7/10 from this thing on the right, we just get m plus 1 over 100. And if we subtract 7/10 from the thing in the middle, we get 3/4 minus 7/10. Now, if we do that long division, that fraction subtraction, we get, over 40. We get 10, we get 30, minus 10 into 40 is 4 times 7 is 28. So that equals 2 over 40. Or what we could call it 1 over 20 if we wanted to, but we'll just leave it as 2 over 40 because we can. Doesn't matter. Now we got to simplify this and see if we can figure out what this m is. So let's multiply everything by 100. 100 times. We're going to multiply all three pieces by 100 times. And then we'll get m, because 100 times m over 100 is m. 2 over 40 times 100 is 200 over 40. And then m plus 1 times 100 is, get rid of that guy. So now what number goes in here? Well, if we simplify this, this is 5, simply the number 5. M is less than or equal to 5 is less than or equal to m plus 1. Well, m has to then be 5. Can't be 4, can't be 6. It has to be 5. So here's our hundredths digit, and we're done because we got an exact match. This number is exactly 5. So this is exactly 5. So m is exactly 5. So our hundredths digit is 5. Our tenths digit is 7. So our number is 0.75. Okay. So this method, we're going to use it over and over again today, and you're going to use it to find, do various calculations. And this is really what your homework is going to ask you to do, is to use this process where we keep iterating and find more and more digits until we're either done or we found a repeating decimal or we've gotten to the digit that the question's asking about. Okay, so here's number 2. We're going to find the decimal expansion of 4/3 not using long division. So the first thing we do here is we know that 4/3 is actually 1 1/3. So our integer portion, our integer part equals the number 1. So we'll just put a box around that. So we got to now convert 1/3. So 1/3 is between, we're just going to find our tenths. We're going to start with our, you know what, let me use different color each time I do a different one. So let's go to orange, and we'll go to tenths. So we know that m over 10 is less than or equal to 1/3, because we already found our integer part. So now we're just going to find our fractional part, and that's less than m plus 1 over 10. All right, so what two tenths digits are between on either side of 1/3? Okay, well, now let's multiply everything by 10. Everything by 10 times 10 times 10 times 10, because we're trying to simplify this m. this m portion. We want to get just this m by itself. So multiplying through everything by 10 is less than or equal to 10 over 3 is less than or equal to m plus 1 over 10. Nope, not 10, just m plus 1. Well, that's m is less than or equal to 3 1/3 is less than or equal to m plus 1. So our tenth digit is 3. Good. So now let's go again. So now we know that 3 over 10 plus m over 100, we're looking for our hundredths digit, is less than or equal to 1/3 minus, 1/3 is less than 3/10 plus m plus 1 over 100. Now we're going to, so we're searching for our hundredths digit. Okay, so now we're trying to get this m over 100. We want to get this m by itself. So now we got to subtract 3/10 from everywhere. So we get m over 100. We subtract 3/10 from 1/3, 1/3 minus 3/10. We subtract 3/10 from this piece. We get m plus 1 over 100. Now let's multiply everything through by 100. And we say, well, well, no, we got to simplify this guy. So let's see. Let's do it over here. Get 1/3 minus 3/10 equals something over, so 30 is our common denominator. So we get 3 into 30 is 10 times 1 is 10. Minus 10 into 30 is 3 minus 9. So we get 1 over 30. Okay, so now we have m over 100 is less than or equal to 1 over 30 is less than m plus 1 over 100. Now we want to get the m by itself, so we multiply everything by 100. So we get m is less than or equal to 100 times, right? 100 times 1 over 30 is the same as 100 over 1 times 30. So that's 100 over 30, and that equals 10/3. So now we have m is less than or equal to 10/3 is less than or equal to m plus 1. Well, we've already had this. We've already figured this one out. If m is less than or equal to 10/3 is less than or equal to m, then m must be 3. And so 3 is our hundredths. So when you get a copy of something and you know what that something is, you can just say m is 3. And so we're going to keep getting the same thing over and over again. So you get 0.333333, which is 0.3 bar. So that's our tenth, hundredth, thousandth, etc. And remember, our integer part was a 1. So our final number is 1.3 bar. I know this is a little bit tricky, a little bit wordy, but it's the method that we're learning in class today, and it teaches conceptually how you can go about finding each digit. And again, we haven't done any long division. We've just done basic, simple integer division, the first decimal, and then we keep going. So that's kind of cool. That's worthy of a happy cat. Okay, let's go one more time. Now we're going to find the hundredths digit in 4/7. So this isn't, it's not doing a full decimal expansion. We want to stop when we get to the hundredths. You have a homework problem sort of like this. So how do we do this? Well, we know this is between 0 and 1. 4/7 is less than 1 but greater than 0. So we don't have an integer portion. So we want to find our tenths digit. So that looks like this. Same thing we've been doing. Okay, so what is the digit? What over 10 is just smaller than 4/7 and just bigger than 4/7? 4/7 is between 2/10, and this is the way we're going to find which tenths it's between. So now we're going to try and solve for m, so we need to multiply everything through by 10. I'll just do it once. Look at that. Put my 10 times over here, so we'll say m is less than or equal to 40/7 is less than m plus 1, m plus 1. And remember, this is our tenths. We're finding our tenths first. Well, 40/7 is the same as 5 and 5/7. So m is less than or equal to 5 and 5/7 is less than m plus 1. So our m must equal 5. So m is 5. That's our tenths digit. Now let's find our hundredths digit. Okay, so we know we're going to come back up here and we'll say, well, 5/10 plus, and now we're going to find our hundredths digit. Is less than or equal to 4/7 is less than 5/10 plus m plus 1 over 100. You know, we found our tenths digit. We're looking for our hundredths digit. So now we got to subtract 5/10 from everywhere. So we get m over 100 is less than or equal to 4/7 minus 5/10 is less than m plus 1 over 100. Let's write that again over here. M over 100 is less than or equal to 4/7. And I'm going to change this into a half because I can. 5/10 is the same thing as a half, is less than m plus 1 over 100. Now we're going to multiply everything through by 100. And we get m is less than or equal to, we didn't do this subtraction, so let's do that now. 4/7 minus 1/2 equals over 14. 7 into 14 is 2. 2 times 4 is 8. Minus 2 into 14 is 7. 7, 1/14. Okay, 1/14 is less than m plus 1. Oh, whoops. Sorry. So this is still over 100. Let's just leave these over 100 for a second. Now we're going to multiply by 100. Boom, boom, boom. Now we get m is less than or equal to 100 over 14 is less than m plus 1. Well, this is 7. 100 divided by 14 is 7 and change. So m is less than or equal to 7 and 2/14. Well, let's see. 14 into 100, right? That's 7, 8, 2, 98, 2. Right, so that's 2 left over 14. It's less than m plus 1. So our m here is equal to 7. So this is our hundredths. Okay, so if we wanted to keep going, we definitely could, and we would start here, and we would say m over 100, or sorry, no, we would say 7 over 100 is less than or equal to 1/7 sorry, looking for our thousandths digit now, plus m over 1,000 is less than or equal to 1 over 14 is less than 7 over 1,000 plus m plus 1 over 1,000. And we can keep going, dot, 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 using the same strategy, but we don't need to, because all the question said is find the hundredth digit in 4 over 7. And the hundredth digit is 7. So we know that the 10th digit was a 5, the hundredth digit was a 7. So our final answer is going to be 0.57 dot, 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 dot. But we can stop because, again, we're looking for the hundredths. Now, if you wanted to keep going, you would use this method here. You would start with this inequality, and then you'd bring it down here, and then you would just start searching for the thousandth digit. And I'll tell you, if you wanted to look for that thousandth digit, your answer is going to be a 1. Your thousandths will equal a 1 for those of you who are really trying to get it and go through it. But we're not going to do that. We're going to keep moving along and do some more homework help. Now, what is the decimal expansion of 13 over 11 without using long division? Okay, so let's do this one. So first of all, we know that 13 over 11, this is the same as 1 and 2 elevenths. So 1 is our integer portion. So now let's look at what is 2 elevenths. Now we need to figure out this 2 elevenths as a decimal. So let's go ahead and use our strategy. And we'll say, well, 2 elevenths. And this one's an interesting one because it's going to repeat, but it's going to repeat after 2 times. M over 10 less than m plus 1 over 10. Okay, multiply by 10. M is less than 20 over 11 is less than m plus 1. So m is less than 1, and 9 elevenths is less than m plus 1. So m equals 1, and this is our tenths. That's our 10th digit. Now let's move along and let's go to light blue. How about? And so now we want to keep going, and we say, well, we know our 10th digit is 1, so we're going to go 1 over 10 plus, and we're going to look for our hundredths digit. M over 100 is less than 2 elevenths, which is less than 1 over 10 plus m plus 1 over 100. Okay, so let's subtract 1/10 from everywhere and get m over 100 is less than 2 elevenths minus 1/10 is less than m plus 1 over 100. We got to do this subtraction, so we get the common denominator is 110. 20 minus 11. So m over 100 is less than that, less than or equal to. These should all be equals to. Doesn't really matter in this problem, but if in some it will matter. M plus 1 over 100. This is 9 over 110. So m over 100 is less than or equal to that, is less than or equal to m plus 1 over 100. Multiply everything by 100, and you get m is less than or equal to 900 over 110 is less than m plus 1 over 100. Nope, not over 100, just m plus 1. And so this here is 8. M is less than or equal to 8. Oh, we could take these ones off here. 8 and 11 into that is 2 elevenths. It's less than or equal to m plus 1. So the hundredths equal to 8. Okay, so now let's take this guy up. We'll do this one in dark green. And then we say, well, 8 over 100 plus m over 1,000 is less than 9 over 110 is less than 8 over 100 plus m plus 1 over 1,000. All right, I'm getting good at this. So let's subtract 8/10 from everywhere and get m over 1,000 is less than 9 over 110 minus 8 over 100 is less than m plus 1 over 1,000. Less than or equal to. All right, good. So now we're going to multiply everything through. Well, we got to simplify this guy. So our common denominator is going to be 1,100. So this is 90 minus 88 is less than or equal to m over 1,000 is less than m plus 1 over 1,000. Let's multiply everything through by 1,000 and get m. And this up here is 2. That equals 2. So is less than or equal to 2,000 over 1,100 is less than m plus 1. Well, this here, m is less than or equal to 20 over 11, because we can get rid of those zeros, is less than m plus 1. Well, we've seen this before. This right here, we've seen it right here. And we know that that is equal to 1/8 is equal to 1. We know that this is equal to 1, and then after that comes an 8. So now we've basically hit our repeating pattern. So our thousandths, or our 1 over 1,000th, is equal to 1. And we have a repeat from earlier, which gives us a 1 and then an 8, and then a 1 and then an 8. So our answer is 0.181818 dot, 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 dot. So and remember our integer portion is a 1, so our final answer is 1.18. It's really important to find, once you get to a pattern like this, m is less than or equal to some fraction is less than or equal to m plus 1, to go and look at all the places before where we had those m is less than something is less than n plus 1 patterns. Because once we get there, we know we're in a repeat situation, and then we can just go find all the numbers that we've hit before and then just start repeating them. Okay? Now, the final thing I want to do is I want to say, well, which is bigger? You know, this is something that we're going to do in the next lesson as well. And it's kind of, it builds on what we learned in lesson 11 and in lesson 12. So this is from lesson 11, how you calculate these. And this is lesson 12. Or you can use long division. I'm going to prefer long division rather than this process that we learned today. But if the teacher says you have to use the process we learned today, you have to know how to do that. So anyway, square root of 3, the way we find the square root of 3 is we know that the square root of 3, right, is between the square root of 1 and the square root of 4. So we know it's between 1.0 and 2.0. Now we need to iterate once or twice on this guy until we get our final answer. Now let's do 18/11ths. Let's do it one more time using the method that we know how. And then we're going to come back over here to figure out what the square root of 3 is. Okay, so let's do 18/11ths. So we know that that's 1 7/11. So our integer part is equal to 1. And then 7/11ths is between m over 10 and m plus 1 over 10. You know, you can pause and try if you want on this one. All right, now we're going to multiply everything by 10, and we'll get m is less than 70 over 11 is less than m plus 1 over, sorry, m plus 1. Keep doing that. M plus 1. So m is less than 6 4/11 is less than m plus 1. So our tenths is equal to 6. Okay, so 6 over 10 plus m over 100 is less than 7 over 11 is less than 6 over 10 plus m plus 1 over 10. Okay, subtract 6/10 from everywhere. M over 100 is less than 7/11 minus 6/10 is less than m plus 1 over 100. This here, 110, we get 70 minus 66. M over 100 is less than that, is less than m plus 1 over 100. So 4 over 110 is less than m over 100 is less than m plus 1 over 100. Multiply everything through by 100, you get m is less than, well, 100 times this is 400 over 110 is less than m plus 1. Well, this is 40 over 11, which is the same thing as m is less than 3 and 7/11 is less than m plus 1. So our hundredths is equal to 3. Okay, so let's go back to here. Hold this guy up and say, well, 3 over 100 plus m over 1,000 is less than 4 over 110 is less than 3 over 100 plus m plus 1 over 1,000. Okay, subtract 3 over 100 from everywhere, and you get m over 1,000 is less than 4 over 110 minus 3 over 100 is less than m plus 1 over 1,000. This guy here, our common denominator is 1100, and that's 40 minus 33. M is less than m over 1,000 is less than that, is less than m plus 1 over 1,000. So that's equal to 7 over 1100, m over 1,000. It's less than that, is less than m plus 1 over 1,000. Now we multiply everything through by 1,000, and we get m is less than 7,000 over 1,100 is less than m plus 1. Get rid of that guy, get rid of that guy, and we have 70. M is less than 70 over 11 is less than m plus 1. Well, we've already seen that right here. And so we know that m is equal to, the next bit is going to be another 6 and then a 3, and it's going to repeat forever because this will get m equals 6. And now we got to repeat because we got copies. So our answer here is 0.63 repeat, and our integer portion is 1. So we get 1.6. One 1.2, 1.3. Well, let's start at 1.5 and see what 1.5 squared is. Is that more or less? Well, 1.5 squared is just 2.25. So we need to keep going to 1.6. Again, this is all from lesson 11, how we do this calculation. 1.6 squared is equal to 2.56. How about 1.7 squared? 1.7 squared is 2.89. Okay, so then 1.8 squared is probably greater. 3.24. So the square root of 3 is between 1.7 and 1.8. So we know the square root of 3 is bigger than 1.7, and 1.7 is bigger than 1.63 bar forever. So we know that the square root of 3 must be greater than 18/11ths, because this is, again, this is, here, let's just do this. This is more than 1.7, and this is less than 1.7. So square root of 3 is greater. So let's happy cat that. So this is kind of where we're going with this unit. We're doing calculations where we're finding, we can now, estimate square roots to n digits. We can estimate or exactly find decimal values of fractions. So we can compare square roots, decimals, and fractions by converting all to decimals. And we know how to see which decimals are bigger than other decimals. So that's where we're going. Hopefully, this is something that's fun. It's definitely going to be, this kind of work is definitely work that's going to be there that you're going to need to do on SAT tests, high school qualification tests, and just simple, straightforward algebra tests. So know how to do this stuff. It's cool. It's neat to be able to look at different representations of numbers and convert between them all. And we're going to be building on this for a couple more lessons, and then we're going to dive into something else. All right, take it easy. Happy cat, happy math.